Good morning. Today we're going to talk about the least recently used page replacement algorithm. I'm Jay Cowell. This is a project for operating systems at Hood College. So what are page replacement algorithms? They are algorithms within the operating system that are used to determine which page will be replaced when a new page comes in. And there are 5 different page replacement algorithms, as you can see in the figure on the right. And today we're just going to look at least recently used. However, you can see that there's also first in, first out, last in, first out, optimal, and random. But today we're just going to look at least recently used. All right, so least recently used is an algorithm that replaces the least recently used page when a new page comes in. And so we're going to look at the following scenario in the figure on the screen. So there's a page reference string 70120304230323, but the page frame is only 4 and it can only hold 4 of those numbers at once. So we're going to talk about how least recently used updates that as new pages come in. All right, so as you can see, let's move down here. As you can see, the first 4 steps are putting in the 7, the 0, the 1, and the 2. So those are like the first 4 like steps as it feeds into the page frame. And 7, 0, 1, and 2, those first 4 steps fill the page frame. So when it gets to the next to be inputted is 0. However, 0, as we already know, is already in the page frame. So therefore, in this segment right here, nothing needs to be updated. And then we go, and so 7 is still the least recently used. So then we get next to the 3, and the 3 needs to be placed in because it is not in the page frame right now. So what we do is, because 7 is the least recently used, we can look at right here, the 3 will replace the 7. And so what we update now is the least recently used, because the 7 is gone. Obviously, it's not the least recently used. And so the next least recently used would be 1, because 0 was already referenced. So that would technically be the next least recently used. However, 0 was referenced again. So therefore, it goes to the 1. All right. So now we move on to the next step, with 1 being the least recently used. And it's a 0 again. No replacement. So it all stays the same. As you can see, this page frame is the same as this. Next is the 4, and 4 needs to be placed in. So what we do now is we use 1 as our least recently used, and we replace the 1 with the 4. So the 4 goes right in the place of where the 1 is, and then now we have to update our least recently used. So we know 0 is not least recently used, we know 3 is not least recently used, so 2. 2 now becomes our least recently used. So next we have to put in a 2 again, and 2 is already in the page frame, so we don't have to replace anything, but 2 is our least recently used. So we have to update the newest least recently used that would be replaced the next time. And so now the newest least recently used would be 3, because as you can see, of the 4 numbers in, 3 is the last one. All right, and so now 3 becomes our least recently used. The next one that we have to put in is a 3. And so it's kind of the same situation that we just did last time, except instead of a 2, it's a 3. And so now nothing changes. As you can see, these 2 steps right here is what we're looking at right now. But nothing changes in the page frame. But all we have to do is update the least recently used in case we get a new number that needs to be put in. So we update the least recently used to 0, because just like when we updated it with 3, the last 4 are all in the page frame, and 0 is now the least recently used. All right, and literally the exact same scenario again. 0, it has to be put in, but it's already in, so now we have to update the least recently used. Let's see with these 3 right here. Nothing in any of this here changes, but we have to update the least recently used to 4, because 4 is the last recently used. used. All right, so now we have to put 3 in again, but 3 is already in. And because 3 is already in and it's been referenced twice in 5, now we have to look at the last 5 to keep 4 as the least recently used because 3 has been referenced twice. Okay. Now, 2, literally the same thing. 4 stays. 4 stays the least recently used. We're not changing anything. And 3 as well. So it's kind of an uneventful example so far, as the last 6 references, we haven't changed anything. Literally, it's all been the same from here on, except the least recently used has changed a couple times, but the last 3 times we haven't changed the least recently used. So that's kind of boring. So let's mix it up a little bit. Let's add in an 8. We want to add in an 8. All right, so we're going to add in another little segment right here. We're going to change that to an 8, change that to a miss, and then we're going to replace the 4. Since the 4 is our least recently used, we're going to change that to the 8. All right, so now the 4 is gone, and we're going to look at the last. Boom, we're going to look at right in here. Never mind, we're not going to do that. We're going to look at right in here. So 0 would become the least recently used. You have 8, 2, 0, 3. So the 8, not the least recently used. 3, not recently used. The 2, nope. 3 again, nope. So the 0. The 0 now becomes the least recently used, and the page reference now, or the page frame now becomes 2, 8, 0, and 3. And so if we wanted to put another one in, say like a 5 or something like that, it would replace the 0 because that's now our least recently used. And so that's just an example of what the least recently used page replacement algorithm does in our operating systems. So thanks for listening. If you have any questions, please feel free to contact me. Yeah, have a good one.